Okay, so today we will start with module 5. Okay, this is the new module, module 5, which is in this module here, you will learn about more arithmetics and logic operations. Okay, so you will learn about the instruction that involve of arithmetics and logic operation. So in the we already finished the what we call here the module 4, okay, on Monday. So let's look at this arithmetic and logic operations. Okay, so the AVR instruction, okay, actually can be divided into four broad classes. Okay, first one we call it as a data movement and memory access. Okay, so for this one here, you're going to move a data from your GPR to your memory, or memory to GPR, GPR between GPR and so on. Okay, so this is what we call it as a data movement. And then we have a data processing, okay, and then followed by a flow control and system control. Okay, for the data processing, you have a arithmetic and logical instructions. Okay, so in this module here, we're focusing on these two, data movement and data processing. Okay, for the data movement and memory access instruction, there are few instructions that we already learned. Okay, okay, so this is your general purpose register. Okay, your GPR, and then you have a stack. You have a constant I/O space, RAM, or your memories or extended I/O, and as well as your flash, your program memory. Okay, if you're going to move a data from GPR to another GPR, okay, you can use the MOV and MOVW instructions. Okay, so this one here, okay, this two instruction here is used to move a data from one register, one GPR to another GPR. Okay, if you're going to move a data from what we call here from your RAM, okay, okay, you can use, okay, to read a data from, okay, to read to move a data from, to read a data from RAM to your GPR, you can use this instruction here, LD, LDD, and LDS. If you're going to save a data from your GPR, or you want to copy a data or store a data from GPR to RAM, so you're going to use the ST, STD, and STS instructions. Okay, why? If you're going to move a data, do a data movement between GPR and your IO register, you can either use the in, okay, to read a data from IO register to your GPR, or out to send the data from GPR to your IO register. And if the data is a constant value, you can use the LDI instruction. Okay, and we have a, if the data is from your program memory or flash memory, okay, to read the data you can use the LPM instruction. Okay, so LPM stand for load from program memory. And last but not least, if you're going to move a data between GPR, your general purpose register, and your to your stack, okay, you can use either push and pop instruction. Okay, so this push and pop instruction you will learn in module 7, if not mistaken, 7 or 8, something like that. Okay, so now we are going to focus on this part here kat sini. Okay, so the first one here is MOV instruction. Okay, so kita dah pernah tengok this MOV instruction, which is this MOV instruction is used to copy the register. Okay, so this MOV instruction used to copy data among your GPR register, which is from R0 to R31. So this is the syntax. Okay, so MOV, RD, and RR, in which your RD is from R0 to R31, while RR is from R0 to R31. So you can use all the GPRs here. Okay, so this is the operation. Okay, by looking at this operation, you know lah what happened is you're going to copy RR, the value from RR, and put to your RD. Okay, you just refer to this operation so you know that what that instruction do. Okay, so for example, I just I just move quickly. Okay, for this part for this data movement, because we already learned about it. Okay, in the previous class. Okay, so you are going to copy content from R0 to R16. So what you're going to do is you just write programming. Okay, mov R16 R0. Okay, why? Because the content is from R0 and you want to copy to R16. Okay, so this is your source register and this is your destination register. Okay, below here, dekat bawah ni, you can see here, this is your status register, your SREG. Yeah, okay, this is your status register. Okay, so in this register here will show you the flag that affected every time you execute a certain instruction. Okay, for this data movement here, if you can see, there are none flag affected. Okay, tak ada pun flag kat sini yang berubah. Okay. Okay, while this is your CPU cycle lah. Okay, CPU cycle means that how many cycle in order to execute this instruction. Okay, for this one here, the CPU cycle is 1. Right, then we have a movw. Okay, so movw stand for copy register word. Means that you're going to copy a 16-bit data. Kalau MOV, you're going to copy a 8-bit data. But this one here, you're going to copy a 16-bit data, 16-bit data. Alright, so movw instruction is used to copy one register pair into another register pair. So this is the syntax. Okay, you see here, this is the syntax. movw rd plus, and then rd, rd plus, and rd. Oh, sorry, rr. Okay, so this is a source and this is your destination. Okay, so by looking at this, what we call here operation here, you know that you're going to copy one register pair, which is consist of 16-bit data, to another register pair. Okay, so it involves 2 register lah. Okay, copy from 2 register to another 2 registers. Okay, so let's look at these examples. You're going to copy the content of R1, R0 to R7, R16. So by using the movw, okay, so you can write down movw R17, R16, R1, R0, because this is your source and this is your destination. Okay, let's say lah, you don't want to use the movw. Okay, you can use, instead of using the movw, you can also use the mov instruction. Okay, how to write down this, how to copy this, how to copy the content of this example here by using the mov is, okay, first you copy mov, okay, by using the, this is the first line lah, mov R17 and then R1, and then another one here is mov R16 R0. Okay, so this one here sama dengan this instruction. The difference is, if you're using this MOV, you're going to use a 2 instruction lah. Okay, you need a 2 line of instruction, but this one here only needs 1 line of instruction. Okay, in terms of processing speed, okay, in terms of your speed, okay, this one here only takes 1 CPU cycle. Okay, this what we call here, this one is 1 CPU cycle, 1 cycle. But this one, if you're going to use the MOV, what happens is you need 2 cycles, okay, to execute this instruction. Okay, both are doing the same thing lah. Okay, to copy R1 the content from R1 R0 to R17 R16. Okay, again, because this is the data movement, okay, none of the status register flags are affected. Okay, and then we have the LDI. So this LDI stands for load immediate. You're going to load an immediate value to your GPR. So this LDI copies 8-bit data into your general purpose register. Okay, so this is the syntax LDI RDK. Okay, because this is immediate data, so your RD, okay, is from R16 to R31 only. Okay, so you need to make sure that your RD, your register that you're going to use is from R16 hingga R31 saja. Okay, what about your K? This K is your constant number lah. Okay, which is from 0 to 255 dalam decimal. Okay, or 00 to FF if you're going to use hexadecimal number, ataupun 0B 00000000 to 0B 11111111 if you're going to use binary numbers. Okay, for example here. Okay, you're going to load R30 with a value of F0. So what are you going to do that? How to do that is you just write down LDI R30, so your register that you're going to load, and then the value that you want to put to that register. Okay, say again, if you see down here, okay, none of your status register flags are affected. Okay, untuk data movement, memang kamu punya status register tak affect. Okay, not affected. Okay, then we have a LDS. Okay, this one also you already learned in the previous class. Okay, LDS stands for load direct from data space. Okay, so this instruction used to load 1 byte data from the memory address to your register. Okay, so this is the syntax LDS RD small k. Okay, so bear in mind this is a small k and this is a capital K. Okay, capital K is what we call here capital K is referred to your constant value, while small k is referred to your addresses. Okay, the address. Okay, so this one, yeah, RD, okay, can be from R0 to R31, while your K is from address 0. Okay, since this small k is your addresses, okay, we refer to your address. So this is starting from 0000 until what address for Atmega 32? Sampai address berapa? Can somebody tell me what is your RAM end for Atmega 32? The end address. Okay, 085F. Okay, so this one here, kalau yang ni, this should be F, 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 F lah. But since we are going to use the Atmega 32, so our addresses started from 0000 sampailah 085F. Okay, for example here, you are going to load the R2 register with a content of address from this one. Okay, let's say lah, this is not Atmega 32 lah. Okay, we are using the another ICs. Okay, so you're going to load a content from this address FF00 to your R2 register. So how you're going to do that is you just write down LDS R2. Okay, and then what is your address? FF00. So after you execute this instruction here, what happens is, okay, so you copy the value, okay, you load the value from address FF00 to your R2. Okay, again, none of your status register flags are affected, and this one here, okay, it takes 2 cycles of CPU to execute this instruction. Okay, next we have LD. Okay, so this LD here used to when you going to do apa ni, what we call here, indirect addressing mode. Okay, we are going to use the indirect addressing mode. So this LD instruction used to load 1 byte indirect from the data space to your register using pointer register X, Y, and Z. Okay, so this is the syntax. You have 3 syntax. Okay, the first one is LDRDX. What happens after you execute this instruction here? Okay, your pointer register X no change, tak berubah. Okay, and then what about this one, LDRDX plus? Okay, means that you load that value, you go to that address that pointed by your pointer register X, look, get that value and put to your RD, and after that your X, your pointer register will increase by 1. Okay, because this is a post increment. Okay, and then the third one here is LDRD minus 1. So what happen is, okay, so this one here, if you see this is the operation ya. Yang ni dia punya operation. If you see this one here, what happen is you need to minus your X dahulu, okay, your pointer register X by 1, and then after that get the value from that address put to your RD. Okay, by looking at this, what we call here operation here, you know what this instruction do. Okay, so that's why I asked you to familiar with the instruction set that I give you earlier. Okay, so make sure you're familiar with that instruction set. Okay, because in that instruction set summary, it have the syntax, okay, and then the what we call it, the operation, as well as the CPU cycles. Okay, so for example, okay, so we go line by line. Okay, clear R27. What happened after you do this one here? Okay, by looking at your instruction set summary, the CLR R27 is you're going to make your R27 equal to 0. So this is what the CLR do lah. Okay, to clear the register value. Okay, and then LDI R26 with 60. So what happened here? R26 got 60. Okay, so this one got 00 lah. Okay, and then LDR0X plus. Okay, so you're going to, what are you going to do here? Okay, you're going to, okay, so since this one here, this LDR0X plus, okay, so you're going to load a data from your pointer register X and then put to your R16. But the question is, what is your pointer register X? Okay, by looking at this R26 and R27, you know that the pointer register X, okay, this is your pointer register X, now pointed to what address? Address apa? Your pointer register X pointed to. Okay, pointer register X is a combination from R27 and R26. Okay, so R27 is 00 and this is 60. So pointer register X now point to address 0060. So you go to this address 0060, get the value inside of this address and put to your R16. And what happened after that? Okay, then your pointer register X now point to new address which is 0061. Why? Because you have the X plus kat situ. Okay, so the pointer register X will increment by 1 after you load, okay, the value to that register. Okay, next, LDR1X. So you're going to load the value from address that pointed by pointer register X and put to your R1. Okay, so what is your current, what we call here, current address pointed by X? Berapa? 0061, which is after you execute this instruction here. Okay, so you go to address 0061, get the value inside of that address and put to your R1. Okay, next we have the SDS. Okay, so SDS stands for Store Direct to Data Space. Okay, so this instruction used to store 1 byte from register to the data space. Okay, so this is the syntax and this is the operation. Okay, and then if you see here, this is a small scale stand for your memory address lah. Okay, so because we use it Amiga 32, so the memory address is starting from 000 until 085F only. Okay, so this is your register. The register that you can use is from R0 to R31. Okay, so this is the example. Okay, LDS R2 FF00. What happened here? You're going to load value from address FF00 put to your R2 and then add R2 with R1 and put the result to your R2 and store the value of R2, which is after you did the addition process kat sini, and store it to address FF00. Okay, and then we have the ST. So this one used whenever you're going to use the indirect addressing mode. Okay, so you have three syntax here. Okay, you have three instructions: STXRR, STX plus RR, and ST minus X RR. Okay, so this one also we already covered in the previous class lah. Okay, so I just move quickly in this part. Okay, then we have a in load an IO location to a register. Okay, so this one here, whenever you see the word in and out, so means that you're going to focus on IO register. Okay, and using the IO address. Okay, so this is the syntax INRDA. Okay, which is your RD is from R0 to R31, while A is your IO addresses. Okay, this A here refer to IO address. Okay, since your IO register, how many IO register you have in Amiga 32? You have 64. Betul tak? So that's why your A is from 0 to 63 lah, which is kalau ikutkan dia punya what we call here addresses is starting from 00 and tukar 63 to what we call here 163 to hexa. What is the value? Can anybody help me? 63 tukar kepada hexa. Is it 2F? 3F? Betul ke 3F? 63. Okay, 3F. Betul eh? Right. Okay, so the address is starting from 000 until 3F. Okay, for example, in R25 address 16 means that you're going to read a value, okay, which is R16 now actually is your port B. Okay, read a value from your port B and put it to your R25. Okay, again, your status register, none flags are affected. Okay, then we have a out, which is out is used to store from register to IO space. Okay, means that you're going to take a value from the register and send it or save it to your IO register. Okay, so this is syntax out ARR. Okay, and this is the operation. Okay, you take the value from RR, put to your IO addresses. Okay, so this is an operand. Okay, your supposedly okay, your RR is come from R0 to R31, while this one here your A is from 0 to 63. Okay, daripada 00 addresses 00 kalau you tukar dalam hexa to address 3F. Okay, so this is for the data movement. Ada soalan tak untuk data movement? Okay, if no question, next we go to data processing. Okay, so for the data processing, you have 4 type of data processing. The first one here we call it as arithmetic operation. Okay, kita ada arithmetic operation, and then we have a logical operation. The third one is your shift, means that you're going to shift your data either to the right or to the left according to this instruction lah. You have a few instructions for the shift, and last but not least is bit operation. Okay, so bit operation is something that you're going to manipulate your bit. Okay, so you have a 8-bit. Okay, which bit that you're going to set and which bit that you're going to clear. Okay, that is a bit operation. Okay, so first we're going to look at the arithmetic operation dahulu. Okay, for the arithmetic operation, you have a few instruction. Okay, that you need to know. Okay, so the first one here is ADD. Okay, the first instruction for arithmetic operation is ADD. Okay, so ADD stand for add without a carry. Okay, so this instruction used to add two registers without the C flag and place the result in the destination register. Okay, so this is the syntax. ADDRDRR, in which your RD and RR can be from R0 to R31. Okay, and this is an operation. By looking at this operation, you know that you're going to add value from RD tambah dengan RR, and the result of this addition you put to your RD. Okay, so let's look at these examples. Okay, ADD R1 R2. So what happened here? You're going to add R1 tambah R2 and put the result to your R1. What happened to your R2? Is it your R2 value? Okay, is it the content of your R2 will disappear or change after you execute this instruction? Or the value remains? Mana satu? Okay, so the value of R2 will remain. Okay, sama. Only the R1, the value will change. Okay. And then ADD R28 R28 means that you're going to add R28 tambah dengan R28 and put the value to your R28. Okay. Okay, then you see here. Okay, there are few flags affected in your status register, which is H, S, N, V, Z, and C. Okay, total number of 6 flags affected after you execute this instruction. Okay, so let's look at this one here. Alright, show the status of C, H, and Z flag after the addition of 38 and 2F in the following instruction. Alright, so what you're going to do is, okay, so we'll just go line by line lah. Instruction by instruction. Okay, the first instruction here, what happened? Your R16 sama dengan 38. The second instruction, R17 sama dengan 2F. While the third instruction here, you're going to add R16 and R17. So what happened is R16 sama dengan R16 plus R17. But since this one here, okay, it asks you to find out what is the status of this flags here. So what you're going to do is, better you convert this hexa value to binary number. Okay, tukarkan dulu value ni ke dalam binary, and then after that you can see lah what happened to this flags after you did the addition process. Okay, so 38, how to convert this one here to binary numbers? Okay, you can use either what we call here your calculator. Okay, the calculator is allowed, yeah, for microprocessor class. For this class, this course, the calculator is allowed. Okay, you can use your calculator compared to when you take the what we call here digital electronic, you cannot use your calculators. Okay, so this one 38. What is 38 kalau kamu tukar dalam binary? 00111000. I assume that you know lah how to convert this value to binary number. Okay, then you have 2F. Okay, 0010 and 1111. Okay, then you tambah lah. Okay, you add these two number here. Okay, 0 plus 1 you get 1. This one 1. 1 plus 1 you get 0. And you have a carry here. 1 1 0, and then you have another carry 1 plus 1 plus 1, you get 1 1. Okay, you have a carry there 1 and 0. Okay, now we're going to find what is your C, H, and Z. Okay, first, what is your C? C 0. Kenapa 0? Because there are no. Okay, so this is your. Okay, so before that, okay, so let's label our bits kat sini. Okay, so this is a bit kosong, bit 1, 2, 3, followed by bit 4, 5, 6, and 7. Okay, C, you need to focus on the bit 8. Is there any carry from bit 7 to bit 8? No carry means that you put C0 lah. Okay, and then H, what about H? You need to see, is there any carry from bit 3 to bit 4? In this case, you have a carry, so your H become 1. And while for Z flags, okay, you need to see the result after you did the addition. Okay, in this case here, okay, you get a value. You are the value. Okay, after you do the addition process, you have a value, so the Z become 0. Okay, when there is no value here, means that the value of R0 is 0, R16 is 0, then your Z flag become 1. Right, so this is for the ADD. Okay, so this is another example lah. Sama juga. Okay, you're going to check what is the status of C, H, and Z flags. Okay, again, what you're going to do is convert lah this value here, hexadecimal value to your binary number. Okay, so 9C is 10011100, while 64 is 01100100. Okay, then you add this number here, so it becomes 0, 0, and 1 plus 1 you get 0, and you have the carry. 1 plus 1 you get 0, you have a carry. 1 plus 1 0 carry, and this one I have carry. 1 plus 1 1 0 carry. 1 plus 1 0, and you have a carry. 1 plus 1 you get 1 0. Okay, so you have a carry kat situ. Okay, next we're going to find out what is your C, H, and Z flags. Okay, C. Okay, so look here, you have a carry beyond bit 7, so C become 1. What about your H? Okay, so you looking at this bit here, there is a carry from bit 3 to bit 4, so H also 1. What about Z? Since this value here, okay, no value which is kosong, okay, your R20 got 0, so Z automatic equal to 1. Okay, so any question up until here? This is for the ADD. Ada soalan? No soalan. Good. Semua senyap je. Alright, next we go to the ADC. Okay, so ADC stand for add with a carry. Okay. Tadi previously no carry. Okay, so we just ignore the carry value. But this one we need to take the carry value to our addition. Alright, so this subtraction used to add two register and the content of your C flags. Okay, and then place the result to your destination register. Okay, so this is the syntax ADC RD RR. Okay, in which RD and RR can be from R0 to R31 lah. Okay, and then this operation, kalau kamu tengok dekat sini, if you look at this operation here, you know that RD must plus with RR and with a C. Okay, you need to see lah, what is your C flag. Is it your C flag is 0 or 1? If 0, you put plus with 0 lah. If your C flag is 1, then you need to plus with 1. And put the result to your RD. Okay, so for this one here, okay, there are 6 flags affected, which is half carry, sign bit, and then you have the overflow, negative number, 0, and carry flags. Okay, let's look at these examples. Okay, you are going to write a program to add two 16-bit number. Okay, kamu ada dua 16-bit number. The numbers are, okay, so this is the numbers. Okay, 3CE7H. Okay, sometimes this H here represent your hexadecimal number. Okay, so the H at the behind of these numbers here actually your hexadecimal number. So you know that the first number is 3CE7 and the second number is 3BTH. Okay, you're going to add two numbers, which is this number, it is a 16-bit number. Okay, since this is a 16-bit number, what you going to do? Apa kamu kena buat? Since this one here is 16-bit number. Okay, you need to divide it lah. Okay, so you need to divide it, this number here, because this is a 16-bit, 16-bit, you can divide it to low byte and high byte actually. Okay, so this one is your low byte, and while this one at your left is your high byte. Okay, this is a low byte and this is your high byte. Okay, and then assume that R1 have 8D, R2 have 3B, R3 got E7 and R4 got 3C. Okay, so inside of this register here already have this number. Okay, so why not we just put, okay, so this one 3C sudah ada dalam 3C dalam R4. Okay, and then while 3B is inside your R2. Okay, this one inside of R2. And E7 is inside your R3 and this one is inside your R1. Okay, so now you're going to, and then satu lagi dia bagi tahu, place the sum in R3 and R4. Okay, so R3 should have the lower byte. Means that after you did the operation, the add operation, okay, so you need to put the result to your R3, which is your low byte, and R4 is your high byte. Okay, so how to do that? Okay, macam mana nak buat? Okay, because this is your low byte and this is your high byte. Okay, this is your low byte and this is your high byte. Since your low byte here, you can use this one, you can use the ADD instruction. Okay, tambah without a carry. But for the high byte, you need to add with a carry. Why? Kenapa? Sometimes, okay, after you did the addition process dekat low byte, sometimes it will produce a carry at the higher byte. So that's why, okay, for the high byte, we're going to use the ADC. Don't use ADD. If you use the ADD, wrong lah. Okay, because if the low byte produce a carry, then you cannot add the carry inside of your high byte here, which is the jawapan will be wrong lah. Okay, so just rule of thumb, okay, low byte you can use the ADD, and then after that you need to use the ADC. Okay, so what you going to do is, macam mana nak tulis program untuk tambah these numbers here. So ADD, okay, since the value is already inside your R1, R2, R3 and R4, so no need to load that value lah. Okay, if this value here is not in it's not in your register, so you need to load the value first to your register, and then after that you do the addition process. Okay, so ADD, okay, so kita tambah yang, okay, we need to do the low byte first. Okay, we need to add the low byte first. So E7 is R3 and this one is R1. Okay, so we need to use R3 R1. Kenapa R3 R1? Why not ADD R1 R3? Kenapa tidak R1 R3? Why? Anyone? Okay, because you need to store the result inside your R3 and R4. So that's why we put R3 as a destination while R1 is your source. Okay, then after you execute this one, so it will produce a sum here, and sometimes it will produce a carry. So the next one is you're going to use a ADC R4 and R2. Okay, since this one here, if you see there is a carry there, so automatic the what we call here, okay, your status register, okay, this is your carry punya flag, become 1. So after you execute ADC R4 R2, so what happen is R4 will plus with R2, which is 3C tambah dengan 3B and plus your carry here 1, and then put the result to your R4. Okay, so that is for the ADC lah. Okay, tolong tukar yang ni, this one ya. Not ADDC, it's only the ADC. Okay, next we have the ADIW. Okay, so ADIW apa pula ni? ADIW. ADIW stand for add immediate to a word. Okay, ADIW instruction is used to add immediate value. Okay, so the value should be from 0 to 63 to a register pair and place the result in that register pair. Okay, so this is the syntax. ADIW RD plus, okay, then you have a colon, RD, comma with K. Okay, so this one here, you can, if you look at this one here, your D should be, you can use R24, R26, R28, and R30 only. Why? Because if you use the R24, the register pair here is R25, R24 lah. Okay, if you put there your D is R26, so the register pair is R26 and R27. Okay, so you need to use this register only. Okay, this register pair only. What about your K? Your K should be from 0 to 63. Tak boleh lebih daripada tu. Okay, if lebih and then you got error. Okay, syntax error. Okay, so for example here, ADIW R25, R24, 1. What happened is you're going to add, okay, so this is your R25, R24. Okay, you're going to add with 1 and put the result to R24 and R25. Okay, and then we look at this one. ADIW ZHZL with 63. What happened here? You want to add two register pair from ZH and ZL, okay, which is R31 and R30, okay, plus dengan 63. So this 63 you convert to hexa lah nanti ya, and then put the result to R30 and R31. Okay, so this is the flag affected. Only 5 flags are affected. Okay, let's look at another examples. Okay, first, load IZL13. So what happened here? You put 13 to your ZL. But since this is a decimal value, so you need to convert to hexadecimal. So 13 in hexa, what is the value here? 13 dalam hexa. A10 A, B, C, D. Okay, so 0, D. Okay, then you have load IZH53. So ZL, so this one here R, what ya? R30 sama dengan 0D. And then ZH is R31. Okay, 53 convert to hexadecimal, kamu akan dapat berapa ya? 35 ya? 33. 53. Okay, and then ADIW R31, R30, 26. Okay, so you need to ni lah. So this is your, okay, R31, R30, which is inside of this register here you have 0D and 35. Okay, then you need to add with 26. But this 26 is decimal number, so you need to convert to hexa dahulu. So what is the hexa for this one? Okay, 1A. Okay, then after that you add this number, so you manage to get dapat berapa? So this one is 27 and this is 35. Okay, so this is the value that you get. Okay, any question for the addition process? Ada soalan tak untuk addition? Okay, for addition you have 3 instructions. The first one is ADD, second one is ADC, and the third one is ADIW. Okay, if no question, I think we stop here, and the rest will continue in next week. Okay, boleh ya? Okay, so thank you class.